Here's a history hot tip from Minute Earth. In the early 1800s, scientists figured out that when they shot tiny particles at a wall with two slits cut in it, those particles didn't go through the slits. They went around them, spread out like waves around obstacles until they hit the detector where they made two distinct bands. This was weird. If each particle was a little ball, it should have gone through one of the slits and landed in only one spot on the other side. But it wasn't a ball. It was a wave. Now, depending on what you're made of, you might be thinking, duh, waves go through slits and make bands. Okay, so far so good. But what happens when we try to figure out which slit the particles are going through? Because if it's a wave, does it matter if we're looking? Turns out it does. When we put detectors at the slits to figure out which slit the particles are going through, the bands disappeared and all we saw was one spot. As soon as we started observing which slit the particles were going through, they stopped acting like waves. They acted like balls. Welcome to quantum physics, where science starts making no sense. So why does looking change what you see? Why do particles care about whether we're watching them? There are lots of ways to measure this, but basically, it's by putting these detectors at the slits, we've collapsed the possibilities down to a single outcome. Instead of there being two possible places the particle could go, now there's only one. And since we know which path it takes, we know exactly where it will land. No more wave, hello ball. This is kind of crazy. If you've ever been to a magic show, you might have seen a magician pull a coin out of your ear after asking a volunteer to pick one, knowing exactly which ear they chose. But how does the magician know? Well, because they set the entire stage and wrote the rules of the experiment. So they knew all along what was going to happen. And in the case of the double-slit experiment, that's kind of what's happening too. But don't worry, this isn't some elaborate setup. It's not like the researchers are rigging the experiment. They're just following the rules of quantum mechanics. This is the best way we currently know of to describe the universe at the smallest scales. And while it doesn't make sense to us, it works. And if you want to get even deeper into how and why this works, you can check out our series on quantum physics. We have links to that and everything else we talked about today down below. So what does any of this mean? Well, here's one way to think about it. Maybe life is like that too. What you choose to focus on becomes your reality. When you look at a blurry photo and realize it's out of focus, you might still be able to make out the general subject, maybe a friend's smiling face or a cool car. But the more you focus on details, the more the photo falls apart. It's the same with life. If you focus too much on the details, the little things you can't control, the things you're observing closely, then that's all you'll see. But if you step back and look at the big picture, then you might see things more clearly. Of course, sometimes you have to look closely in order to take action, like when you're diagnosing an illness or figuring out how to fix a leaky faucet. But generally, it's a good idea to take a step back from the details every once in a while. Maybe that's why we have eyes in the back of our heads. Literally, if you look around you, you'll see that the world is full of magic. All the stuff that makes life worth living, beauty, creativity, innovation, joy, love, all that stuff. That's the big picture. So step back, take it all in, and try not to get too caught up in the details. That's our advice for the day. We hope you enjoyed this episode. If you did, you can like and share it. If you haven't already, please subscribe and follow us for more fun science stuff. Thanks for coming on this journey with us to explore the big questions of the universe and beyond. This is our show. We'll see you next time.